Hello everyone, welcome to my video lecture tutorial. This time I will be talking about 2D rotation of an object. Here we want an object to rotate like this, clockwise or counterclockwise. So how it's done is that to rotate a polygon or other graphics primitive, we simply apply the same rotation transformation to all of its vertices. This means that when we want to rotate an object, we will consider all the edges and the vertices separately, and we will apply the same rotation transformation formula. In this particular case, we use 30 degree. We apply 30 degree, and then once we apply this object will be rotated a little bit. Here in this case, the angle that it makes will be 30 degree. Okay, so this is how rotation is done. To rotate an object, first of all, we need to consider a particular point of an object. Let us consider a particular point of an object, that is x and y. And this x and y, we want to rotate it to x dash and y dash here. How can we rotate this particular point of an object is that we will apply the formula x dash will be equals to x cos theta minus y sin theta, and y dash will be equals to x sin theta plus y cos theta, because we want a rotation of an angle theta here. Okay, so let us try to recap a little bit about geometry, so that we will not get too lost on why we need sine theta and cos theta. Is that suppose we have a right triangle here. This is your 90 degree, and here is your theta. Here is your hypotenuse, this is your base, and this is your perimeter. Okay, so using trigonometric identities, we know that sine theta is equals to perimeter by hypotenuse, and cos theta is equals to base by hypotenuse. This means that this side will be your cos theta side, and this side will be your sine theta side, so that we can change the angle using this cos theta and sine theta. That is why we can come to these particular identities and formula. Now let us consider this point again. Now we know that we have theta here. This is in your angle theta here. But what about this angle phi or phi? This angle is taken so that the angle is in between the point of an object and your x-axis. Okay, here is your y-axis. Now how do we come to this conclusion is that, first of all, let us consider this point with respect to the x-axis, x and y point with respect to the x-axis. This is your x-axis. Now we know that if this is your x-axis, suppose we draw a line here, which is your, suppose we draw a line here, this is your right angle, which is perpendicular to the x-axis, and we have a phi as an angle here. Now taking this formula that we have discussed before, x will be equals to nothing but r cos phi. Okay, because we know that cos phi, in this case here the angle is phi, in this case cos phi will be equals to base by your hypotenuse. Your base is nothing but your x, which is equals to x by your hypotenuse is taken as r. All right, so x will be equals to cross multiplication, we have r cos phi. All right, and likewise we also know that sine phi will be equals to perimeter by hypotenuse. In this case, your perimeter is your nothing but your y, and your hypotenuse is nothing but your r. All right, so take this value of y will be equals to r sine phi. All right, we get this now. Okay, now let us take an example of x dash y dash. Here x dash y dash with respect to the x-axis is that we have theta plus phi here. This true will be the angle for x dash and y dash, so it will be theta plus phi. Okay, so x dash will be equals to r cos theta, sorry, r cos phi plus theta. Y dash will be equals to r sine phi plus theta. All right, this is the formula that we get. Now, using trigonometric identity, we know that r cos phi cos theta minus r sine phi sine theta, y dash will be equals to r sine phi cos theta plus r cos phi sine theta. This is the trigonometric identities that we already have. Okay, and when we substitute the value here, substitute the value of r cos phi and substitute the value of r sine phi, we have r cos phi is equals to x, so we have x cos theta. R sine phi is equals to y, now you get minus y sine theta. Okay, likewise y theta is equals to r sine phi. R sine phi is nothing but your y. Okay, r sine phi cos theta, here you get it, r sine phi cos theta, y cos theta, plus r cos phi is nothing but your x sine theta, x sine theta. Okay, so this is your formula for rotation of an object. Now let us move on. The formula that we have is already this. Now we are going to capture this in a matrix form, because when we actually calculate it using a matrix form is very easy and simple, because all we have to do is to multiply two matrix and then we get the answer. All right, so when we actually multiply this matrix, we will get the same answer. We will get x dash will be equals to, remember that we will go like this and then it's like this. Okay, so the first one will be x cos theta plus, now we have y minus sine theta, and when we take out the negative sign, we will have x cos theta minus y sine theta, which is the same thing as this. Taking the value of y dash, we will have x sine theta plus y cos theta. Right, this is your matrix form. To represent a 2D transformation by a matrix, we multiply matrix by a column vector, apply transformation to point. This is simple an example. I have just explained it here. X dash will be a into x plus b into y. Likewise, c into x plus d into y. Okay, this is how matrix multiplication is done. Now, we have already studied translation, scaling, and rotation, and these are the three formulas for 3D transformation. The first one is your translation, the second one is your scaling, and third one is your rotation, represented in matrix form. These are all your matrix form. These are all correct. But how can we make this homogeneous? That means here we have plus, and the other two are all matrix multiplication. Just take an example of 2D translation first. If we are going to make it composite matrix, using homogeneous coordinates, we can express the equation that define a 2D translation of a coordinate position simply like this. Okay. Now these are actually the same thing. It will give out the same thing. Example here, x dash will be equals to tx plus ux or x plus tx. It doesn't matter. Y dash will be equals to ty plus y. Okay, this is the formula that we have. Now, this particular homogeneous coordinates matrix will also give the same results like this. X dash will be equals to, take the value of x dash. 1 into x is x plus 0y, 0 into y, plus tx into 1. Okay, which will be equals to x plus tx. Sorry, x plus tx, which is all the same. Okay, now consider y dash. Y dash will be equals to 0 into x plus 1 into y plus ty into 1, which will be equals to 0 plus y plus ty, which is nothing but y plus ty. Okay, same thing. Now consider 1. 1 equals to 0 into x plus 0 into y plus 1 into 1, which will give 1 is equal to 1. Okay, this is anyway, which is unnecessary, but to make it homogeneous we are making it like this. Okay, so using all this formula, the transformation in matrix representation will be like this. So in your exam, the final formula that you will have to write for translation, scaling, and rotation is this formula. Okay, in your final exam, write this formula. All right, that is all for today's transformation. Thank you for watching, and I will see you on the next class. Thank you.